Alright, let's start. Alright, so I want to discuss this question, the exercise. Alright, number 2. Okay, figure show a man pushing a lawn mower with a force of 90 Newton. Resolve the pushing force into its horizontal component and vertical component. Okay, so basically when we want to resolve, what it means by resolve here is we want to split the force into two components that is perpendicular to each other. So we call these two components the horizontal component and vertical component. So for example, you look at here, this is a 90 Newton force at the angle of 60 degree from the vertical. Okay, so this is vertical and this is the direction of the force. Okay, 90 Newton. The angle is 60 degree. Okay, 60 degree from vertical. So what we want to do is we want to split. We say resolve, we use the word resolve. Resolve, that means it's like we break it apart. We break it, the 90 Newton into two component forces. Okay, we want to split or resolve resolve this 90 Newton into two forces that are perpendicular to each other. So we label this as the horizontal component and the vertical component. So the horizontal component usually we label as Fx, and the vertical component we label as Fy. Okay, so basically we split this 90 Newton into these two components. So it means that these two components, Fx and Fy, will be able to produce the same effect as this 90 Newton. That means the effect of this 90 Newton is the same as this Fx and Fy. The effect of Fx and Fy is the same as the 90 Newton. Okay? Get the idea? Alright. So we want to find this horizontal component and the vertical component. So the concept that we use is the parallelogram. That means the length of the side of the parallelogram represent the magnitude of the force. Okay, so the parallelogram that we can get is like this lah. Okay, so this is the 90 Newton. Okay, this is the 60 degree. Alright, so since the length of the parallelogram and the diagonal line, the length represent the magnitude of the force. So basically, if you calculate the length, you can get the force is how much. You can get this Fx is how much, you can get this Fy is how much. Okay, so from this parallelogram, we can get a triangle. Okay, a triangle. So a triangle that looks like this. Why look like this? Because I get from this part. Okay, because I get from this part. I take the triangle from here. If you don't want to take from here, you want to take from this down here also can. Okay, you have two right angle triangle. Okay, so let's say that I take this one, the top here. Okay, I take this one, the top here. So this one is the Fx. This is 90 degree. Okay, and because this is 90 degree, this is 60. So that means here it is 30 degree lah. So this one is the 90 Newton. And this one, because this is a parallelogram, right? Parallel. So that means this length and this length is the same. This length and this length is the same. So that means this length is the same length as Fy lah. So this is the length that represents Fy also. Okay. Alright. So now since we get a right angle triangle, so that means we get a right angle triangle and the length of the side represent the magnitude of the force. So that means if we calculate the length, we can calculate the force is how much. So this again, this is a right angle triangle. So we can use trigonometry to calculate the length of the side. Alright, so I think I erase this part so that we have more space. Okay, so that means, okay, so you see if you want to calculate this fx, this is adjacent, right? Not adjacent. So if you want to calculate this fx, we can use cos. So cos 30 degree, so equals to 90. Equal to cos is adjacent over hypotenuse. So adjacent is fx. Hypotenuse is the 90 Newton. So fx will be 90 multiplied by cos 30 lah. So you should be able to get 77.94 Newton. Okay. After that, this one is opposite. Okay, this Fy is opposite, so we can use sine. Sine 30 degree equals to Fy over 90. So Fy will be equal to 45 Newton. Alright. Okay, so any question? So this fx is the horizontal component and this fy is the vertical component. Alright, so get already horizontal component, vertical component. Alright, so B, if got question please ask because this is asking question is a very important process of learning. Okay, it's a very important and the most simple way to learn. Okay, you have problem, you ask, and then I can straight away explain to you, solve your problem. Alright, B, state the function of the horizontal component and vertical component of the pushing force when the lawnmower is being pushed. So what is the function of the horizontal component? Okay, so this horizontal component is like this. So that means this horizontal component is responsible to make this lawnmower move forward. Okay? So we answer horizontal component push the lawnmower forward, and then the vertical component, okay, the function of the vertical component is to push the lawnmower downward. Okay, vertical component push lawnmower downward to cut the grass effectively. Okay, effectively or efficiently also can. That means basically it means that you can cut the grass better if you have a force pushing the lawnmower downward. Okay, get the idea. Okay, this question number 3 is want us to calculate the resultant force. Okay, this question is not, it doesn't want you to find the component of the forces, but just to calculate the resultant force. Okay, so you see these two forces, they are not perpendicular to each other. Okay, they are not 90 degree. Previously we learned that if it is not 90 degree, then we have to use the scale diagram. That means you draw diagram to you draw a scale diagram where the length of the diagram represent the magnitude of the force, and by using ruler to measure the length of the lines, you can get the magnitude of the resultant force. Okay, so what is resultant force? Just a reminder lah. Okay, a resultant force is a force that have the same effect as these two forces combined. Okay, so for example, we have 5 Newton and 9 Newton acting on this object. So logically, this object will move somewhere in this direction, right or not? Okay, this object is not going to move in 9 Newton, the direction of 9 Newton, and also not going to move in the direction of 5 Newton. But the object is going to move in the direction somewhere between these two forces. Okay, so how to find, so if this, basically it means that if we want to find the resultant force of these two forces, the resultant force of these two forces is the force that can also make this object move in this direction, same as these two forces, same effect. So the force that can give the same effect as two other forces combined, that is resultant force. Okay, alright, so the way that we can calculate and the way that we can find the resultant force is using the concept of parallelogram, same like just now. That means we use the length of the line to represent the magnitude of the force. So we have 9 Newton, here we have 5 Newton, this angle is 60 degree, and the resultant force is somewhere in between here. Okay, so this is the resultant force. So if we complete the parallelogram, we can get a diagram or a parallelogram that look like this lah. So here this line is the same length as this one, this line is the same length as this one. So this line also represent 9 Newton, this line also represent 5 Newton. Okay, now we want to calculate this. This here we don't want to use the scale diagram method. We want to learn how to calculate. Okay, so that means we want to calculate this length. Okay, so from this parallelogram we can get triangle. Okay, we can get a triangle. So the triangle that we can get is, you can get either from here, you have one triangle here, or you can get this part, another triangle. Okay, either one also can lah, no problem. So let's say that I take the green one. Okay, so we have triangle that look like this. This one is 9 Newton, this is 5 Newton. Oops. This is 5 Newton. This is the resultant force that we want to find. Here is 60 degrees, so that means here is 120 degrees because this and this is parallel. So here 60, here 120. Parallel, a line that cut across, so that means the total angle here will be 180. So that means here the angle will be 120 degrees. So how to calculate this force F? Trigonometry also, but not the normal cosine tangent lah. You have to use something that you learn in additional maths, which is the Cos Rule. Okay, cos rule. So if you still remember, the cos rule is like this right now. Okay, okay, for example, a square equals to b square plus c square minus 2bc cos a. Okay, so that means this f, if this f is a, this 120 will be this one a. Okay, so this 9 and 5 will be b and c. Okay, so this ABC is the length of the side. This one A is the angle. Okay, so if this is angle A 120, so that means this F is A. Okay, so these other two side is this one B, this one C, or this one B, this one C. It doesn't matter lah. Okay, it doesn't matter. Alright, so we substitute in the value. So this A is the force. So this B is 9 square, this is 5 square minus 2. 9 times 5 cos 120 degree. So using your calculator, you will be able to get 12.288 Newton. Okay, so this 12.288 Newton will be the length of this line, and the length of the line represent the magnitude of the force. So the resultant force, this force is equal to 12.288 Newton. Okay, let's look at B. For B is like this. One force here, another force here. This is 60 degree. So logically, if there is a 5 Newton pushing in this direction, 9 Newton pull in this direction, so logically the object should move somewhere in this direction right now. Okay, logically the object should move somewhere in this direction. So this 5 Newton push have the same effect as 5 Newton pull in this direction. If you have 5 Newton here, it's the same as you have 5 Newton here. 5 Newton push, same as 5 Newton pull. Okay, this is 9 Newton pull in this direction. So we can get a parallelogram that look like this. This is 9 Newton, this is 5 Newton, and the resultant force should somewhere in this direction. So we can get a parallelogram that look like this. This one is 5 Newton, this one also 9 Newton. So this is the resultant force. So here is 60 degrees, so that means over here will be 120 degrees. Okay, if here is 120, so that means here will be 60 lah. Alright, so same thing, if you want to calculate this length, we need triangle. So you can either get triangle from here or from here. Okay, so let's say I take the green color one lah. So I get triangle that look like this. Okay, so we want to calculate this f. Again, we can use the cos rule. Okay, a square equals to b square plus c square minus 2bc cos a. So this a is the force, F square equals to bc 9 and 5. 9 square plus 5 square minus 2. 9 times 5 cos A, so the angle A will be 60 degree. Okay, Alright, so calculate, and then you can get the resultant force is 7.81 Newton. Okay? Okay, question number 4. Santiran pull a 5 kg crate on the floor with a force of 35 Newton. The friction against the box is 8 Newton. So what is the acceleration of the crate? Alright, so this is 25 degree, 35 Newton. So if you want to calculate the acceleration of the crate, you see, what is the direction of acceleration? Logically, pull in this direction, 35 Newton. So this crate should move in this direction, right now. Okay, move in the direction that is horizontal. So the acceleration should also be the same direction. Okay, but you see the force 35 Newton is 25 degree upward, not horizontal. Okay, not directly horizontal. So that means actually this 35 Newton, only a part from the 35 Newton is responsible to make the crate accelerate forward. The other part is upward. The direction of the force is one part horizontal to the right, one part is vertical going upward. Okay, so if we want to calculate the acceleration, we want to calculate the force that have the same direction as the acceleration. So this is the force that is responsible to produce this acceleration. So we want to find this force is how much. And this force comes from this 35 Newton. And this force is horizontal. So this is the horizontal component of the 35 Newton. Alright. So this is horizontal adjacent to the 25 degree. So that means we can use cos. Why? Actually this one is also same thing, which is based on the parallelogram. So that means like this. This is 35 Newton. Here we have this one fx. This one is 25 degree. Okay. Here we have Fy. This Fy is not important because the question doesn't ask you about any force that is going upward, so you can ignore. Okay, so the parallelogram is like this. This one is Fx. This one is also this one is Fy. Here is 90 degree. Okay, so if we want to find Fx. Fx is our objective. So this Fx is adjacent to 25 degree. Okay, and you can see that here there is a right angle triangle. Okay, so we can, because this is adjacent, so that means we can use cos. Cos 25 degree equals to fx over 35. So fx equals to 31.72 Newton. Okay, 31.72 Newton. So now we have this fx, which is the horizontal component that is responsible to make the crate accelerate forward. So we can use this to calculate the acceleration. So F equals to ma. This force gives this mass this acceleration. So this is a force. Fx is a force that gives this crate this acceleration. Okay, so the force will be 31.72. Mass is I forgot that. There got friction. Okay, got friction. So if got friction, so that means that this force that is responsible for this mass to have this acceleration, this force is the resultant force between 31.72 and this 8 Newton, because they are opposing each other. 8 Newton is in the opposite direction of the 31.72. So here it will be 31.72 plus the friction -8. So equals to, the mass is 5 kilogram and the acceleration is the one that we want to find. So acceleration, wait. Okay, continue. So the acceleration that we will get is 4.744 meter per second per second. Okay? Anybody have any question? Okay, number 5. Okay, find the horizontal and vertical component of the force. Okay, find the horizontal and vertical component. Alright, so the force is this direction. Okay, 200 Newton. Okay, 200 Newton. So this is the direction, 33 degree. Okay. So the horizontal component will be in this direction. This is the horizontal fx, and this will be the vertical component fy. Fy is downward. Okay, the vertical component is downward. The horizontal component is to the right, because this force is in this direction downward, in this direction to the right and down. Okay. Okay, so this fx is the adjacent, because if we draw a parallelogram, then it will look like this. Okay, so this is the fx, this is the fy. Okay, this is the 200 Newton, this is the 33 degree. Okay, so same like just now, we can get a triangle. Okay, we can get triangle from this parallelogram. Okay, we can get triangle from here. Alright, so where were we? Okay, so we want to find the horizontal component and the vertical component. So this, we can get a triangle from this one. Either here, this one, this triangle, or this side. Okay, both also can. So let's say that I take this one. Okay, let's say that I take this triangle. Okay, right angle. This is 200 Newton, 33 degree. So this is fx, this is fy. Alright, so this fx will be adjacent. Okay, adjacent to the 33 degree. Okay, so adjacent, so we can use cos. Alright, cos 33 degree equal to fx over 200. So fx we can get 167.73 Newton. For your information, the new syllabus, okay, I just for the new syllabus, the requirement for your answer is minimum is 2 decimal place. That means if your answer, for example, after you calculate from your calculator, you get 167.7333, for example. So minimum you must write is 167.73. More than that, no problem. Minimum 0.73. That means 2 decimal place. That is the minimum. Okay, that is the minimum. In physics, you can write as long as you want. You want to write the whole thing also can, no problem. But minimum is must be 2 decimal place. Okay. And then for the vertical component, so because it's opposite, so we use sine. Sine 33 degree equals to Fy over 200. So Fy equals to 108.93. Okay, 108.93 Newton. So this is the horizontal component and the vertical component. So almost everybody can get lah. Okay, almost everybody can get. Okay, so next B. Part B, what they want is what is the weight of the concrete roller. So weight equals to the mass multiplied by the gravitational field strength. So mass is 250 kilogram and the gravitational field strength we use 9.81. Okay, so we will be able to get 2452.5 Newton. So this is the weight of the roller. Okay, after that they want us to calculate the total downward force. Okay, so what does it mean by total downward force? Just like what you say, you take all the force that is going downwards and you add them together. So for example, weight is also a downward force, right? So you take the weight, you plus the the vertical component. Because the vertical component, this Fy is also downward, right? Okay, this Fy is also downward. This weight is also downward. So you take the weight, you plus the vertical component. Okay, so total downward force is 2452.5 plus 108.93. So you get 2561.43 Newton. Okay? Any problem? Okay, one question here, because I see some of you put negative. Okay, put negative. For example, this one you put negative, this one also you put negative because it's downward. Okay, actually it's correct lah. You put negative for downward force is correct, but however, in this case, you do not need to put negative. Why? Because here you already say that this is a downward force. So this total downward force here in the name already say that it is downward. So you do not have to put the negative. Actually, if you put negative, then it will be incorrect because you already say that this is downward force, but you put negative, so that means it will be the opposite of downward. That means upwards. You get the idea? But some of you do not write. If you didn't write total downward force, you just write like F equals to how much? Okay, for example, you just write F equal 2452.5 plus 108.93 equal 2561.43 Newton. If you just write F, then you need to specify. Okay, then you need to answer the question. You need to specify. You need to write that this is total downward force. Okay, total downward force equals to how much? Okay, total downward force equals to how much? You need to specify that this answer means total downward force. Okay, that is the best way to answer lah. Okay, so again, if you already write total downward force equals to how much, then you do not need to put negative because it's already mean downward. Get the idea? Okay, so next, C. Okay, C. Okay, C, it says that if the gardener pull the handle with the same force in a reverse direction, what is the total downward force on the ground then? Okay, so you see, when it is in the opposite direction, like this, 200 Newton, 33 degree. So the vertical component become upward. You see the vertical component become upward. So to calculate the vertical component which is upward, actually is the same because this one Fy here is also Fy here. This one is Fx. So it's still opposite. It's still sine 33 degree equals to Fy over 200. So you still get 108.93 Newton, but this time is upward Okay. So now it's saying want you to calculate the total downward force. So you write total downward force is the weight plus this vertical component. So the weight is 2561.43 plus this 108.93 is in the opposite direction. That means it's going upwards. So you need to put negative 108.93 to show that this is in the opposite direction, which is upward Okay. So equal to 2343.57 Newton. Okay. So this is the total downward force when we pull the roller. Okay. So D, the question asks, in which direction pushing or pulling will the roller be more effective in leveling the grass? Okay, so it will be pushing It will be pushing. Why pushing is better? Because the reason is very simple. Because larger downward force. Okay, larger downward force like that. Okay, so very simple. Okay, number 6. Diagram show a box of mass 20 kg on an inclined plane with 30 degree from the horizontal. Okay, frictional force between the box and the inclined plane is 100 Newton. Okay, what is meant by frictional force? Okay, so here it asks for definition. What is frictional force? So frictional force is a force acting in the opposite direction as the motion between two surfaces in contact. Okay, frictional force is a force acting in the opposite direction as the motion between two surfaces in contact. Alright, so this is definition for frictional force. Okay, B. Calculate the weight. Okay, what is the weight of the box? Okay, so here it says that the box is 20 kilogram. Okay, 20 kilogram. So, okay, weight W equals to the mass times the gravitational field strength. Okay, so the mass is 20 kilogram, gravitational field strength is 9.81. So you should be able to get 196.2 Newton. Okay, 196.2 Newton. After that, calculate the resultant force parallel to the inclined plane. That means they want you to find the force that is in this direction. This is the resultant force parallel to inclined plane. Okay, parallel to inclined plane. That means you take this force plus this friction, 100 Newton. Okay, plus this friction, 100 Newton. Okay. Okay, so first we want to find the horizontal component, or the component of the force that is parallel to the inclined plane. Okay, so you see, this is the weight. Okay, this is the weight. So because of this weight, the box is pushing onto the surface. So that means there is a force that is pushing on the surface of the inclined plane. And because of the weight also, there is a force that can make the box slide down the inclined plane. Okay? The important part here is you must realize that the box pressed on the surface because of weight, the box can slide down because of weight. So that means the force that push on the surface comes from the weight. The force that make the box slide down also comes from the weight. Right now, if you have no weight, then the box will not push on the surface. The box will not slide down if there is no weight. Right. So that means that these two force, okay, is the component of weight. Okay, is the horizontal component and the vertical component of weight. Alright. So if this is 30 degree, here is also 30 degree. Okay, here is also 30 degree. Alright. So by using, from here we can get a parallelogram. So I draw the parallelogram so that you get an idea lah. Okay, get an idea. Okay, so the parallelogram is here. Okay, or like this. Okay, here is 30 degree. This one is the component that is parallel to the inclined plane. This is the component that is perpendicular to the inclined plane. So this is the same. This is also Fx and this is also F1. So this side is 90 degrees. So we can get a triangle again. So from the triangle, we can see that this Fx is opposite the 30 degree. So we can use sine 30 degree equals to Fx over the weight. Okay, how much is the weight? The weight is 196.2 Newton. Okay, so that means so it means that the component that is parallel to the inclined plane is 98.1 Newton. Alright? Okay, now this is 98.1 Newton. Opposing force 100 Newton. Okay, this 100 Newton is friction. Okay, so one thing that I need to inform you to make sure that you know about friction is, if it says that the frictional force between box and inclined plane is 100 Newton, what it means is that the maximum friction between box and the inclined plane, between these two surfaces, the maximum friction is 100 Newton. You understand what I'm saying? That means if the force, that means this horizontal component, this Fx is only 98.1 Newton, that means less 98.1 Newton, which is less than the maximum friction. That means that the actual friction that will act against the 98.1 Newton is also 98.1 Newton. You understand what I'm saying? Okay? The friction will follow, the magnitude of the friction will follow the force that is acting on the object. That means like this. Okay, I explain a bit. Example. Let's say we have a surface. Okay, we have a surface and we have an object on this surface. So if the friction is 100 Newton, this is the maximum friction, 100 Newton. So that means that if you push the object with 50 Newton, then the actual friction that will act is 50 Newton also. Okay, I repeat, if the question say that the friction between two surfaces is, okay, if the question say friction is 100 Newton, that means this is the maximum friction. Understand? So for example, if like this, if the maximum friction is 100 Newton, that means if you push with 50 Newton, then the friction will act 50 Newton also. Okay, so the object cannot move. If you increase until 99 Newton, then the friction also will increase until 99 Newton. Okay, so the object will not be able to move. So all you need to do is, if you increase the force until 100.1, then what happens to this friction? The friction will only be able to increase until 100 Newton. So that means what happened to this object? You see, there is an extra 0.1 Newton. So this 0.1 Newton is the resultant force. So this resultant force of 0.1 Newton will be able to give this mass acceleration. So this object, this mass will be able to accelerate because of this extra 0.1 Newton. Okay, get the idea. So that means what happened to this box? The horizontal component, or the component that is parallel to the inclined plane, is 98.1 Newton. So that means what? The question asks. For resultant force. Okay, B2. The question asks for resultant force. So the resultant force is 98.1 plus negative 98.1 also. That means this negative 98.1 is the friction. Understand? Friction. So that means the resultant force will be 0 Newton. Okay? The force that want to make the box move is only 98.1. So the friction also can increase until 98.1 only. So the resultant force will be 0. Okay, the resultant force will be 0. Okay, so C, based on your answer in B2, explain what happened to the motion. So what happened? This is part C. So part C, what will happen? The box can move or not? Yes, very good. The box cannot move lah. Okay, the box will remain stationary. Okay, box remain stationary. Okay, get the idea. The box will remain stationary. Figure show a horizontal force F act on a wooden block of weight 8 Newton, placed on a smooth plane inclined at 30 degrees to the horizontal. What must the magnitude of F be to prevent the block from sliding down? Okay, so that means this one need to be how much? Then only you can stop the block from sliding down. Here it says that this is a smooth plane. So smooth plane meaning there is no friction. If no friction, that means the horizontal or the component that is parallel with the inclined plane from the weight will be able to make the wooden block slide down. Okay, that means this Fx from the weight 8 Newton will be able to make the wooden blocks to slide down. So you need another force to stop this Fx, to counter this Fx. So the force that counter the Fx must be in the opposite direction of Fx. So this force that stop or counter the Fx come from where? Come from this F. Okay, so that means this force, okay, let's say this is Fx1, this is Fx2. That means this Fx2 is the component from this F. Okay, so we need to make sure that this Fx2 will be equal to the Fx1 in order to calculate how big is this F. Okay, alright, so first we build the equation to find Fx1. Okay, so this Fx1 is the opposite here. Okay, fx1. If you construct the parallelogram, so this fx1 is opposite to the angle here. So this angle is 30 degree. If this is 30 degree, then here will be 30 degree also. Okay, so that means fx1 will be opposite the angle. So we can calculate by using sine. Sine 30 degree equals to fx1 over the 8 Newton. So fx1 equal to, okay, so 4 equals to, f equals to, okay, so this f, so the force F will be 4.62 Newton. Okay, 4.62 Newton. Alright. So again, this Fx1 is the force that is parallel to the inclined plane. So this Fx1 is a component of the weight, and it can make the wooden block slide down. So in order to stop the wooden block from sliding down, you need Fx2, which is in the opposite direction of Fx1. So this Fx2 is the component of the F, this force F here. Okay, so here we calculate that the Fx1 is equal to 4 Newton. So Fx2 equals to 4 Newton because Fx2 must equal to Fx1 in order to stop the Fx1. Okay, so Fx2 equals to 4. So here, to find the F, because Fx2 is adjacent to the 30 degree, so cos 30 equals Fx2 over F. Fx2 equals 4, so the force F must be 4.62 Newton. Alright.